In this video, I'm going to be explaining what combined variations are. And a combined variation is one in which a variable varies directly or jointly with some variables and at the same time varies inversely with others. Now, that means that we'll have both a direct and an inverse variation in the same equation, so I'll show you how to set that up. Combined variation. Here's an example of a combined variation problem. This problem says if y varies directly as x and inversely as z, y is 22 when x is 4 and z is 6. Find y when x is 10 and z is 25. So we know that if I had y varies directly as x, you know that relationship would normally be y equals k times x, right? But at the same time, I've got y varying inversely as z. So what I'm going to do is once I write that direct variation relationship down, I'm going to ignore the x for a moment, act like it's not there. So let me just cover that up with something. And then I'm going to write a relationship where y varies inversely as z. So y varies inversely as z would be y equals k divided by z. So now I have that it varies inversely with z and directly with x. So this is the relationship that I would use. So the rest of the process is pretty much the same as what we've been doing. You have a complete set of information. Y is 22 when x is 4 and z is 6. So you plug that in to get k. And there's many ways of solving this thing for k. I would probably multiply by 6 and divide by 4. I think, let's see, that would give me 132 over 4. And that would simplify down into 30, well, let's see, 33. So my relationship in this problem then is y equals 33 times x over z. And then you use the incomplete information to answer the question. Find y when x is 10 and z is 25. So find y when x is 10 and z is 25. So that would give me 330 over 25, which simplifies down to something like 66 over 5. So 13.2 if you wanted to do a decimal. Now, here's a word problem that's a combined variation problem. The maximum load that a cylindrical column with circular cross-section can hold varies directly as the fourth power of the diameter and inversely as the square of the height. Boy, there's a lot going on there. So I'm going to focus on that sentence so I can write the relationship out first. So it says the maximum load, so let's give that a variable name, let's call it L. The cylindrical column with circular cross-section can hold varies directly as the fourth power of the diameter. So let's call the diameter D. So if I just focus on that relationship, the maximum load varies directly as the fourth power of the diameter. And then it says it varies inversely as the square of the height. So again, I'm going to ignore for just a moment this, and I'm going to build everything around that L and that K. So it needs to vary inversely as the square of the height, so that would normally be L equals K over H squared. So now I have that inverse relationship. Whoops, diameter will support 64 metric tons, so that means 9 meters in height, trying to find K, 2 meters in diameter will support 64 metric tons. So that's going to give me something kind of big. Let's see, 64 times 9 squared divided by 16 is K, because I multiply both sides by 9 squared and then divide both sides by that 2 to the 4th. That would give me 4 times 9 squared, which is 4 times 81, so that's 324 is my K. So my relationship in this problem then is 324 d to the 4th over h squared. And then you answer the question. How many metric tons can be supported by a column 9 meters high and 3 meters in diameter? So it says 3 meters in diameter and 9 meters high. So 3 to the 4th is 81, and 9 squared is 81, so those cancel. So the answer is 324 metric tons.